Hello friends, welcome back to another video of Ubuntu series. So in this video we are going to see storage management and file system management and the configurations. So we would be seeing how to configure a disk because we are using a VM, so we'll be looking at from the VMDK perspective or the virtual disk perspective, but it would be almost the same if you are working on an actual disk or the LUN, right? So we will be seeing that. We will be seeing the logical volume configuration. We would be seeing how to create partitions, and then we would be seeing how to mount a disk as a static mount or how to mount storage volume as autofs, right? So all that we will be seeing in this video. So let's start with this. Okay, to do the partitioning, we need a disk. So I'll be using my Ubuntu 02 machine for this demo. So I will need to add another disk here. So we'll go to the settings, we'll go to the storage, and we'll go to the controller here. And then we will add another controller here. I will add a SCSI controller, and then we'll add a disk, and we'll create a new disk. So I'm using VMDK for this. We'll go next, and we'll keep this dynamically allocated, and we'll put this as split into files of less than 2 GB. So this will create shorter files, and if we suppose want to move that VMDK to a USB device or another machine, we can move it easily. So that is what it is written here too, right? So we'll use VMDK and we'll go next, and let's change this to the 5 gig. That's all I need for the demo, and I'll change the name as demo uh, fs. Okay, so this would be the name of my VMDK, and let's create it. So see, demo fs.vmdk is created, virtual size is 5 GB, and it is attached to the SCSI port 0. So if you see here, that is also SCSI port 0, and here also it is SCSI port 0. So now this is disk which is added to our machine and created. So let's power on this machine now. Okay, my machine is powered on, so let's log into the machine from putty. Oh, see, if you haven't seen my video of tips and tricks, I have configured user one and configured it to log in with a key. So it was easy login, just a double click. So let me switch to root. Okay, so I'm logged in now. Okay, so uh, to start, we'll start with the basic command fdisk, which is pretty common to be used in Unix for partitioning and for disk. So let's do fdisk-l. So what it shows all the disks on the server. So if you see here, this is SDA, which is our root file system disk, which is being used in 3 partitions, and this is our new disk of 5 gig, which we will be using for this demo. Okay, so if you just want to see a particular disk, you can do that too. I mean, if you want to do like this, you can do something like this too to show a specific disk. So before I go into the partitioning, let me show you something how to scan that disk. So uh, nowadays, on my experience, I have been seeing that the LUNs or the SAN disks are going away from use. I mean, people are starting to use the virtual machines like VMDKs or the cloud storage or the NFS storage over the network more than the SAN storage. So what I'm going to show you is how to scan a new disk or a new LUNs which comes from the SAN. But you might not be needing it. And again, if you reboot a server, it automatically scans it, and like if you see here, we already see the STB. But if you are doing this in the enterprise environment where the server is already on and you are adding a new VMDK or you are adding a new LAN and it is not visible to you, you have to scan your SCSI ports or the fiber channel ports, whatever ports you have to, right? So let me just show you that. So this is where you see all that. So it is sys class, and then if you see sys class, you will see here multiple options. So if you see here iSCSI host, similar way you have the SCSI host, and if you having the fiber channels, you will see the fiber channel host, also FC host. So because we have added the disk as a SCSI host is, so if you see here, we'll go to the SCSI host, and here we will see host 1, host 2, host 3, and then this is where we got to scan it. So if you do like this, host 0 suppose, and you have to scan all the hosts, so and this is the command. So this is what you need to run exactly. So echo oops, echo, and then dash dash dash, and then you have to do something like this to scan a particular host. So what this dash 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 is, that is your controller target and number on your HBA device. So in this case, our HBA device is the VMDK, the OVM, which is controlling it. So that is where we are seeing the host, right? And at times you would need to identify that which target or which host exactly you are adding the disk on, or you are extending a disk. So what happens if suppose if you are having two disks of the same size and you're extending one, you need to identify which disk has been extended, or you can just rescan everything, or you can find it from the VMDK and from here that which target controller you are running that disk on, and then just scan that particular disk. Okay, so this is what you will run. But like I mentioned, this is normally not needed nowadays. Earlier it used to be when we were using LUNs or multipathing and all that, but yeah, that's going away. Okay, so let's come back to the fdisk. So for fdisk, to create a partition, what we would do, fdisk and the device name which we just created. So whatever your device name is, okay. So I'll do fdisk stb. And now if you see, it is saying M for help. So we'll just hit M. So to show all the options. So it will show you all the options which you can use. Okay. So we'll go by the first option, which is pretty common, is P, which means print. So right now it is saying that this is the disk, 5 gig is the size and all that, and there is no partitions in it, right? So now let's create a new partition. So to create a new partition, you give n. So if you see here itself, it says primary and extended and for free. So you cannot have primary partitions more than 4. So if you want to have the partitions more than 4, you have to create the extended partitions, and on top of extended partition you can create the logical partitions. So let's move on, let's create a extended partition. So we did E, and then it is asking partition number 1, so I'll leave it default, and then it is asking first sector, we'll leave it default, and then it is asking the last sector or the size. So what we are going to do, we'll create it of 2 gig. So to give a size in gigs or megabits, you have to use plus sign and give something like this. So if you see here, it is saying created a new disk of extended size 2 gig. Okay. So now if we do print again, it says SDB1 and type extended, right? So now let's do a new partition again to create a logical partition. So now if you see here, you have options P and L, that is primary and logical now. So we'll create the logical partition, and now if you see here, this has changed. So 1 extended, 3 free, right? So if it was just primary, you can create 4 primaries, or if you want to create logical volumes, you have to create 1 extended, and you can still create 3 primary, and on top of that 1 extended, you can create multiple logicals. Okay, so this is how it works. So let's create another logical one. So we'll give L here, and again it is asking a start first sector, so we'll give default, and now we'll give 1 gig out of that size. So let's do 1 gig. Okay, and if we see now the partition, it says SDB1 and SDB5, two partitions are created. Okay, so let's create one more partition. here. So let's do this. Let's create L and see the default for sector has changed. It is not what it was on earlier one, like 4096. That means it was starting from very scratch, but now it is starting from where this partition ends. Okay, so if you see here, this was the end sector for the partition SDB5. So now it is starting from after that sector. Okay, so we'll give this default, and again we'll use the rest of 1 gig for this partition. Okay, so it is saying value out of range, so that happens very commonly. So if you see here, this used the sector until 47, and after that it is using sector 296, right, not immediate 247. So between those two sectors there is some space which is left out, and that is why we are not seeing the complete 2 gig out of our first extended partition, right? So that's why it is saying 1 gig is not allowed. So and that is why I wanted to show you this. So we will do just default, so it will create whatever size is available to it. So if you see here, it is saying 1022, so it is missing 1024. That means 2 megabits are missing from 1 GB. That's why it gave the error. Okay, but now if we see the partition, it says 1 gig of HTTP5, 1 gig almost of HTTP6. Okay, so this is the partitioning. Now let's do the type. So T is for defining the type of that partition. So generally we use logical volume or the LVM for the partitions. So we are going to define that partition. So default it is asking 6. That means it is going to define SDB6 type, or if you want to change it for 5, you can give 5. So let's use 5, and then it is saying the types. So if we give L, it will list all the types. So if you see here, it is 8E. It must be somewhere here. Yeah, here 8E for Linux LVM. So that is what is commonly used for LVM if you want to use your partition or disk for the logical volume. So let's change that to 80. So now if you do the P, it says extended Linux LVM, and let's leave this as Linux itself. Okay, so you have to write it. So the partition table is altered now. Okay, so now if you see fdisk-l dev stb, you will see all that partition information, right? But if you would have quit without doing w and you have entered q, you would have lost all the partitions which you created. Okay, okay, so now partitions are created. So there is another command which is not very much needed nowadays with OS being very intelligent. So part probe. So what it does, it tells OS for the differences whatever you made in the partitioning. Okay, but like I said, nowadays it is not very much needed. But if you're not seeing your partitions and you're not able to do anything on your partitions, you have to run part probe to let OS know that new partitions are created, okay, or the partitions are modified. So that is another command. Now we want to mount it. So to mount it, we have to create the file system on those partitions. So to do that, let's create mkfs start ext4 on our simple partition which we did not use as LVM. So let's do this. Okay, so done. So it is pretty quick. What it did, it just partitioned our disk with ext4 file system type. Okay, so let's mount it. So to mount it, we will need a mount point. So let's create a directory at mnt of as stb6 mount point. Okay, and let's mount this our dev stb6, whatever we had, to this mount point. Okay, it's mounted, and now if you see this, it will say SDB6 is mounted and the size is 990, m, because already it was 1022 there, and now once the file system is partitioned, some super blocks are written, some size of that is gone to those blocks, right? So now you have available size as 990m, and a plain partition is something which you mounted successfully now. So now let's use our other partition to see the logical volumes. Okay, so let's see what we have right now as the PVS. Okay, so if we see PVS, that is physical volume display, right? So in short format, so if you see PVS, it is having only STA5, and if we see VGS, it is just one VG created, and if we see LVS, it has only two LVs, one for root and one for. So all these commands display the output in very smaller format, but there is another command which is used which shows a little uh, bigger picture of a PV, VG, or LV. So if you do something like this, it shows you all the details for the physical volume. Same way, if you do VG display, it will show you all the details for that VG, right? All the logical volumes which are created on that particular VG. And same way, if you do the LV display, it will show you the logical volume details, right? Everything, the name, the size, and all the details for the logical volumes which are there. Okay. And if you want to see a specific logical volume or VG, you can surely do something like this, so it will show you only that details, right? And there is another command in VGS which you can actually use, not you might not need it very often, but if you want to use, you can give VGS with options as devices and then LV path. Okay, so what it shows, it will give you the path too. So if you see here on VGS simple, it was not showing you the device and the path. It was just showing you until here VG free. So if you see here, it is showing you the device and the path where it is mounted on the OS also. Okay, so this way you know which disk it is coming from, that particular VG, and you know what path it is on the logical volume, right? Now, let's move on. So when we want to create a new PV, VG, or LV, we have a command to scan our VG, LV, and PV, and it goes by PV scan, LV scan, and VG scan. So if you do this PV scan, it says, okay, there is only one uh, PV found. So once you run a PV create, you can scan it, and you will see that the new PV is shown, right? Okay, so we created a SDB5 1 gig partition for as type Linux LVM. So let's use that to create a PV. So let's do PV create and dev SDB uh, SDB5. So it should create a PV. So successfully created the PV. It's pretty simple. If you have multiple disks you want to create PV on, or multiple partition, you can simply give PV create SDB5, dev SDB6, and whatever you want to, okay, in the same line. So it will create all those PVs. No need to give it on the separate lines. Now let's create the VG. So VG create, and let's give this name as VGWFH. Okay, and then let's give the disk name which is STB5. So see, volume group is created. Okay, now let's create the LV. So to create LV, you have to give the size. So to give the size, there is an option hyphen capital L, where you can give the size in gigs. So we'll use 1 gig here and see what happens, if it is able to create it or not. So we'll use WFH, and then we'll give the logical volume volume group name. So logical volume name, and then volume group name. So see, it gave you the error. The same concept what we were seeing on the partitioning, same applies here. It is not having the enough size as 1 gig to allocate the partition to allocate from the partition to this LV. So it is having only 255 extents, not the 256 what is required. So to do what you have to give in the to check what you have to give in the extent, you can use this VG display, and you can do VG this. So if you see here, it says you the extent size right here, okay, 255, okay, and here is the same information. So if you are not seeing this here, you can verify it from here, okay. To create the LV, now you have to use hyphen small l option, and then you have to give the extent size. So normally you would be using capital L option only because you would be giving in gigs. So for the example, just to show, because it is pretty common that someone says that I have allocated you 10 gig, but when you are going to create the LV, you're not getting the 10 gig, right? Because of all the partition, super blocks, and PVVG writing some data into it. So that is how you would use the extents to create your logical volume. So let's create it. See, logical volume LV WFH is created now. Okay, so now when the logical volume is created, let's mount it. So if we see here LVS, now we have LVWFH created on VGWFH. Now we need a path for that logical volume. So how would you identify that? So let's do this display, and let's see. So if you see here, it says the complete path. So same way it will show you the complete path here. So this is the path. So now you just do mkfs like we did for the plain partition, mkfs.ext4, or whatever partition type or the file system type you want to use. Like if you want to use xfs, you can use xfs. So I'm giving mkfs.ext4 and this path. So done. So now this is also um, yeah, ext4 file system type logical volume. And now let's create another directory at mnt as sdb5 lv mount path, okay, and let's mount this at this path. Voila, so it's mounted. So now if we see, it's mounted again, okay. So again, if you see here, the size is 988 m, not exactly 1 gig, right? So now we have seen how to mount a plain partition which was created from Fdisk, and how to use uh, logical volumes or LVM to create a logical volume and mount that on a Ubuntu server. Okay, so now we are going to see the extension of this logical volume. So let's create a new partition on our SDB. So let's go Fdisk SDB, and if we see here, we have 3 partitions now. So let's create a new one. So now we had created SDB1, the extended partition of size only 2 gigs. So we cannot create a logical partition now on that partition. So we'll create another primary partition. Okay. So now the primary partition number is 2. We'll leave it default, and then it is a starting the default sector from a default whatever it is getting. Let's give it that, and let's create this as 2 gig. Okay, so now let's see. So if we see here, SDB2 is created as Linux partition here. Okay, now let's change the type of that. So we'll do this, and we'll do 2, and we'll give 80 to change it to Linux LVM. And if we see it again, uh, partition, it's Linux LVM now, and let's write it. Okay, So the partition is written, but it is saying device or resource busy. Okay, so see here what I was mentioning you earlier, that you may need to run part probe to let OS know that partitions has changed. Okay, so let's run part probe. Okay, now it should be able to see our SDB2 partition. Okay, okay, and now let's use our SDB2 which we just created to resize our VG. So let's do this VG extend and our VG name, which was VGWFH, and then our new disk name. So it was SDB2. Okay, so see, now if we see the VGS, the size has increased to 3 gig. Okay, so we have extended our VGWFH to 3 gig from uh, 2 disks. So earlier was SDB5, now we have added SDB2 also to the same VG. But because we have added it, LV will not know that it is coming from 2 disks or 1 disk. For LV, it is just the VG. Okay, so now if we see the LVS here, so we have this, right? And we are going to use this free size, that is 2 gig, to extend this VGWFH. Okay, now to extend existing partition or existing LV, you do not need to unmount unless it is a root file system. So if it is a root file system, it is preferred that you unmount it and then you do whatever you want to do. Okay, but for other partitions like the data partitions or the data volumes, you can simply resize it. Okay, so let's resize our LV WFH. So we'll do LV resize and we'll give capital L this time, what we were trying to use there. And now if we try to use plus 1G, it should be able to resize it. Now if we do this resize fs together, it should do that too. So if we give this lv, we do lv wfh, something like this. See what it does, it extends the LV, at the same time it resizes the file system if we give in a single line command. But this you can do in two parts too. So if we see the LVS right now, it will show you LV size as 2 gig, right? Earlier it was 1020, right? But if you want to and if we see VGS, you will have only sorry, if you see VGS, it will have only 1020 MB free. Okay, so if we want to simply resize the LV but not the file system in this command, we'll remove that resize fs here and we'll use hyphen capital L just to give the extend size. So again, it is asking for 255, so we'll give 255 and we'll use hyphen L. Okay, nope. So I uh, missed the plus sign, so just give the plus sign and see. So if you miss the plus sign, it was asking, do you want to override the data, because it was thinking that you want to decrease it to that size. So that is something which we are gonna see in LV reduce, but for now we are increasing it, so it is LV resize with plus sign. Okay, so now it is extended. Now if we see LVS, it is 3 gig, and if we see df-h output, so we are not seeing the 3 gig yet because we have not partitioned, I mean we have not extended our file system. We have extended our LV, but we have not extended our file system. So let's extend our file system. So what we did with resize to fs in single command, we have to do this in another command. So resize to fs command, and then we have to give the path, which is this, something like this. Okay, now if we see df-h, There you go. Let's create another partition quickly. So fdisk dev sdb and p and new, and let's go by p, and let's leave it 3, and first sector is this, and I'm going to use default whatever is available. Let's take it. So let's do p. If you see here, now sdb3 is created with 1023. So this way we are utilizing all our 5 gig now. So let's change the type again for that. So I'm changing for 3, so I'll give 3 and then 80, and then just let's write it, and again I'll run part probe just to let it know the partitioning. Okay, done. So let's create a pv quickly with that vg pv create, and it was dev sdb3. Okay, dev sdb created, and the option which I wanted to show was -s. So in enterprise you sometimes see that you need to mount or partition a disk of more than 2 TB. So with 2 TB disk, the extent size, which is default of 4M, is not sufficient. So that is where you have to change the extent size, and generally what extent size is used is 32. So I change it to 32 when I create the VG, when I am mounting or when I'm creating logical volumes for something more than 2 TB. Okay, so we have given extent size, and then we'll just simply give the new name WFH1 suppose, and the size, I mean the disk. Okay, so VG is created. Now LV create also has an option which I use just to show you. So let's see that option too. So LV create and then -L, and now we are not going to give the extent size, we are simply going to use 100% free. Okay, and then we are going to give the name of LV, so I'll give LV WFH1, and we are going to create this from WFH1 VG. So if you see do something like this, you don't have to give a size, you don't have to give an extent size. Okay, so whatever disk is available in that partition, whatever size is available in that partition, it will take that. So this is pretty commonly used because most of the times you will be using entire disk for your logical volumes. So if you see here, it used whatever was available to it, right? So this is how you will create a VG in other way for bigger disk, and use LV create to allocate entire partition size. Now let's see how to reduce LV. Okay, so I'm not gonna mount this one. It's the same. So let's see how to reduce it. So okay, so this partition is now 3 gig. So let's resize it. So to resize, you need to unmount it first. So let's do the unmounting. Umount, sorry. And then the path. So now it's unmounted. Okay, now if you want to resize it, it has to go the reverse way. So when we were mounting it, we configured the LVM first, and then we did the resize to FS. But when you are doing the reduction in size, you have to do the file system reduction first and then the LVM. So let's do the resize to FS again. And let's give the path, which is this. Oops, not this path, the VG path. So let's give this, and let's give the size to 2 gig. So we are reducing it to 2 gig. Okay, so it's saying we need to run the fsck first on that partition. So that is what you need to do when you are reducing it. Okay, so let's run it. It just checks that everything is good on that disk and there is nothing non-contagious. That means everything is not scattered all around, and which should create issues for you when you are reducing it. Okay, so it says 0% non-contagious, so we can simply reduce it. So let's do the same command again. See, it did the resize. Now let's do the fsck again. Okay, the same fsck. Okay, so if we see here, the size is, the files size is changed, the block size is changed, so file system is reduced now. Okay, now let's reduce the LVM. So we'll do the LV resize now. So if we see LVS right now here, uh, this one is 2.99 gig, right? So now let's do the LV resize. So we'll do LV resize, and the name. Okay, so it is asking, are you sure? Yes, so it is resized. So if we see here, now it is 2 gig only, and let's mount it again. So whatever we had mounted, okay, so this is what we mounted, and if we see the path again, so it is reduced to 2 gig. So this is how you will reduce a file system and a logical volume. But this is not generally which you would be doing in enterprise, because in enterprise data is most critical, so you don't want to corrupt any of your data. So generally you will see creating, increasing resizing, not the reducing resizing. Okay, now we are done with the logical volumes, most of it. So let's just remove the logical volume. So what we'll do lv remove if we want to remove a LV. So whatever the path of LV is, so before you remove, you need to unmount it, right? So let's unmount it again. Okay, and there was one more. So let's do this too, and then see LVS, and let's do LV remove WFH and WFH1. So you need to give the complete path. Okay, so the complete path was VG underscore WFH and LV underscore WFH and VG underscore WFH1 and LV underscore WFH1. Okay, yes, I want to discard it. Yes, I want to discard it. Okay, if you see LVS now, it's gone. The same way you can remove the VG. So let's see VGS now, and let's remove the VG. So here you can give the VG name. Okay, removed. Everything gone, and let's remove the PV2. So PV remove, and STB2, STB3, STB5. Okay, everything is wiped off, so no logical volume now from the STB5. Okay, before we move out of LVM, there is one file which I want to show you, which is get etc lvm and lvm.conf. So this file has the configuration for how lvm works. Okay, so there is a filter thing which is commonly used from this file. So let me show you that. Yeah, here. So if you see here, scan. So if on enterprise there are multiple devices to scan, like I was saying, you can have LANs, you can have SAN. So here we are just having the SCSI devices, so we are just scanning the tab. But if there are multiple other devices which are named differently, you have to scan them. So this is where you would change the filters to scan all the available paths. Okay, so just wanted to show you that too. That's all I wanted to show on LVM. So now let's remove the partitions which we created on SDB. So let's do this SDB and remove it. So to remove the command is D. So default is 6, let's delete it, and again D, default is 5, deleted, D3, oops, default deleted, D2, deleted, D1, deleted. Okay, now if we see, everything is gone. So all the partitions are gone. And if we just write it, it's gone. And if we do fdisk-lsdb, all the partitions are gone and your disk SDB is free to use. So on some scenarios you can use raw disk too, like on the ASM disk for the Oracle. You generally use the raw disk because the cluster itself, the ASM cluster itself manages the disk according to the database or the Oracle, right? So that is where you do not need to partition any of the disks. You would simply have the disk there, and Oracle would configure the raw disk on their ASM cluster, or even on the SIOS cluster. I mean the ERP cluster. If you want to use, you can use the raw disk. So this is all fdisk and lv, but there is another command now which is pretty common to be used in uh, Unix is parted, which does the similar job what fdisk does. So let me show you some of the examples of parted 2 which I have been using. So if we do parted, it says, and the same way like we were saying there, if you do p, it prints the partition table, right? But it is showing you only for SDA. So if you want to see SDB, you just quit from here and do def SDB, and let's see there. So no partitions, right? And everything is available here too. So let's create a partition quickly with the parted also. So here also, if you want to see help, let's see help. So for help here, it is more user friendly. Just type help. And if you see, the commands also are little bit more user friendly, that mkpart, print, and you have to just type whatever uh, that is. Okay, so let's create a uh, partition. So before you create a partition on parted, you generally label the disk. So if you disk or the partition, right? So uh, what it tells what type of partition that is, like if it is MS-DOS, if it is a ext3, ext4, XFS, GPT, whatever label type is. So okay, so parted is pretty common to be used for the GPT partition. So let's create a GPT partition, and then we'll see how we can use parted. So mklabel GPT. Okay, so it is saying everything will be destroyed and last. We are good. So let's done. So this is how you will label it to be a GPT. Now if you want to create a partition, you will just do mkpart and what you want to create. If you see here, it says mkpart part type, okay, then fs type, and then a start and the end. Okay, so we want to create a partition. So if you do mkpart, it will ask you partition name. Okay, so partition name primary or logical, that is what is the partition name. So let's create a partition primary. Okay, now it is asking the file system type, so let's give it ext4, and now it is asking for oops, ext4. Okay, now it is asking for the startup cylinder, so startup location. So let's go by 0%. Okay, so here you can use something like this. So if you want to start from very scratch 0%, you can give 0%. And if you want to use suppose 1 gig of size, you can give 2 gig. Okay, now if we see print, there you go. It has started from 0 percent, that means from the scratch, and then created a 2 gig of partition, primary partition. So that is pretty simple how you do with the parted. And after that, if you want to remove a partition, you just simply give rm, and it is asking the partition number, so we'll do rm. Okay, so this is how it is used, the parted. Otherwise, it is almost the same. You can do fdisk or you can do parted. There is one more command which is pretty common to be used with the parted, and let me show you that. So with parted, the most common command which I have been using is single line command to create a partition. So that is this. So dev sdb, I'll do mklabel, and I'll give GPT. Okay, and yes, it is labeled as GPT, and now I want to use my entire disk as a GPT, as a partition, primary partition. So let's give this, and let's give mkpart primary, and start up from 0% and end at the 100%. So if you see now the parted output, it says it has allocated everything, that is 5 gig, to that partition. And the same output if you want to see from the fdisk dev sdb. Okay, and if you see here, it says 5 gig, so the partition is created with 5 gig with all the available space using parted command. And if you see here, disk label type, it's gpt. Okay, so I just wanted to show you parted, the single line command which I have been using myself. Okay, now I am coming to the configuration files, that is mount configuration files. So when you want to mount something static like this, like a disk, you generally use fstab. So if we see the fstab entry here, so what you would do, you would create a partition and you would give that path. So whatever we were giving in the mount command, you would give that path here, you would give the directory here, and then you will give the file system type ext4. And if you want to use some options with that, like there are multiple options with fstab mounts. So if you want to use some options, or if you want to go by defaults, you can go by the default. So generally we use defaults. uh, okay, so dump means that if you want to back up the disk or dump the disk in case of errors, you would configure it. Normally it is disabled, so it's 0. And the pass, that is for fsck. So if you want to run the fsck when the server is booting up, you can change this last digit. So generally for the root disk it will be 1, and for other disks you can add it as 2 or 0. So 2 is that after the root disk is scanned, your other disk will be scanned, and if it is 0, it will not be scanned at the boot at all. Okay, so if there is error with your disk, it doesn't matter. So this is what fstab is. But the fstab mounts, all the mounts are mounted automatically when the server boots up. Okay, but there is a concept of autofs in Unix, which means that a path is mounted only when it is needed, not all the time. Because if anything is mounted from fstab, that is mounted all the time on the server after the boot up, right? But there are paths like the home directories, user home directories, or something from the nfs, which is just used for some time, not all the time. Or suppose there is a job which runs like once in 3 months, so you don't need that mount path to be mounted all the time on the server, right? So you can just configure that through autofs so that when it is in use you can mount it, otherwise it is not mounted, causing just extra load on the server. Okay, so I'm going to show you the NFS mounts now and the autofs now. So to show that, I have already created some exports on my Ubuntu 03 machine, and I have created the NFS server over there. So I'm not going into the NFS server part here, because again that NFS or the storage part is managed by separate teams, generally like NetApp teams or the storage teams um, who have the storage devices made specifically for the storage, right? So that is on the server side. But on the client side, what we need to do, let's see that. So here, if we try to run this command show mount hyphen e, which is a simple command to show what are the exports from a particular server. So I'm going to use my server name because I have given that in the alias. So if I do this, what it says that it is not available and I need to install NFS common. So on the client side, you have to install NFS common package. So let's install it. Okay, now it's installed. And if we run the same command again, it does show that there are two exports from that server, right? User homes and WFH exports. Okay, so this is a command which shows the exports from a storage server. Okay, which is exported to this particular box and is visible to this particular box. Okay, now let's try to mount this. So what we have already created on let me clear this up. So what we have created on MNT already, let's use that mount path, or let's create a new path. Clear MNT auto, not auto, NFS mount path. Okay, and let's mount one of these paths. So we'll use Ubuntu 03 and this, and then we'll use WFH exports. Okay, so let's do this and try to mount it on here. See, it's mounted. So if we see the path now, it says it is mounted from this server, and this is the path, and this is the mounted uh, mount point. This is the mount point. Okay, now it is taking all the disk size from that server. So wherever it is created, it is taking that size. On the enterprise, you would see that this storage export is normally will be restricted with the user quotas or the specific volume quotas or the filer quotas. Okay, so normally it is like a storage server on top of which we have multiple filers and then we have multiple volumes and queue trees, right? So it will be managed by the storage team and they will define a specific size for that volume which will be given. Okay, so let's move on. So this is how we are able to mount a NFS path here. Okay, so now let's move on to autofs. Now to configure autofs, we need to install other packet which is autofs. See, it is creating all the files for autofs, which we'll be just seeing in a minute. Okay, autofs is installed now. Okay, so this is a main configuration file for the autofs. So if we see here auto.master, okay, so this is what the content of etc auto.master is. Right now there is nothing other than this line uncommented, which means that include any of the files which is on that drop directory path .d drop directory path. Okay, so let's remove one of the lines here. So let's remove this hash to uncomment the dot slash net. Okay, so slash net is pretty common to use in AutoFS. So what it does, let me show you here. So because we modified AutoFS, we need to restart the AutoFS or we need to reload. So let's restart it. Okay, Now it's restarted. So now if we want to just uh, see a path like what we have mounted earlier, right? From Ubuntu 03, like if we see this path, right? So if we just want to see this without even mounting it, we can do that. So we can do something like this with simple /net. See, it is accessing that path with autofs net, right? And if you see here, this is the path. It is not mounted anywhere. It is just auto mounted at /net path, and it is accessing that same export from Ubuntu 03. Okay, so that is one of autofs uh, uh, concept which is commonly used. Okay, /net. Now we have direct and indirect maps in autofs. Okay, so what that means, so we'll see that too. So to see that, let's modify our auto.master again and add a couple of lines. Okay, so let's go to the end and let's add this, and let's add a file name auto.direct. Okay, and let's add home and etc auto dot home. Okay, so what this means, so this means this is the path, and this is a file which would be used for the direct maps, and this is a file which would be used for the home home maps. So this would be a indirect map, this would be a direct map. So how that makes the difference, let's see. So we have modified this, and let's create those two files. So let's do vi etc auto.direct, and let's mount that same path to somewhere on root. Oops. Um, so let's mount it as auto underscore direct. And what was that path? Let's take that path from here. So I gave the mount point name, and I'm giving the export path. Okay, and let's write this, and let's create a home file also. And here we would give something like this. So here also we can give the same way, but that is not is which is very good way. So generally with home, what is used is this. So we have another export from Ubuntu 02, if we would have seen in show mount here, user home. So I'll be using this for the user homes, and we can give something like this. So what it means, it will check for a user whoever logs in for that user ID, and it will match the directory name on that export path from Ubuntu 03, and it will try to mount that path when user tries to log in. So this is a indirect map. So we are not defining the directory, we are not defining the path like we did in the direct map. We define the directory, we define the mount path, we define the mount point, right? But if you want to do that here, you can do that too. So if you want to do something like this, you can give like user one, and if you want to specify the user one path, you can do something like this. Okay, but we are not going to use it because that is not what is used in enterprise 2, because there are a lot many users. You're not going to define individual users in auto home, rather you will use the default which I have configured here. Okay, so both of the files are configured. Now let's restart our autofs again and see what happens. Okay, it's restarted. So let's see what we have configured in auto.direct. Oops, this was the path. So let's try to cd to that path. See, we are able to cd it. So we did not create it, we did not create a mount point, we did not create that directory here. When a user tries to access it with cd, he simply is able to access it without mounting, without configuring it anywhere in fs tab, right? So whenever user needs to access it, he can access it simply by using respective commands like cd, ls, or whatever commands he wants to run from that path. So this is a direct map where we define the mount point, where we define the export path. Okay, now for the user home directory path. So let's try to log in with user one again. Okay, so I'm opening the duplicate session. I'm giving the password. So I'm logged in. Now if we see here, see my home directory is already mounted as home user one from this NFS export. So when user 1 logs in, it will mount user 1. When user 2 logs in, it will mount user 2. And the same way, it is gonna, like if we try to just uh, simply switch to user 2, let's see what happens. And if we see now, so see, the user 2 mount point is mounted. So with respective users, it is going to mount the respective path from the NFS storage. So this is another reason to use autofs. So when that user logs off, that mount path automatically unmounts. And like I said, this is all governed with the user quotas on the storage at the storage and by the storage admin. So every user will have their own quota of storage which they can fill up to, right? So that is how you would configure the auto mounts, or how would you mount something on the Unix server with autofs. Okay, there is another uh, file which I would like to show you before I close this video, and that file is etc autofs .conf. So here what I would like to show you is this interval, timeout interval. Okay, so if you see here, the timeout is 300 5 minutes. So every 5 minutes, if user path is not in use, it will unmount it. So if you want to increase it, you can increase it from here. And there are other configurations too in this autofs.conf if you have to use it. Okay, so this was all I wanted to show on this video. So thank you. Thank you for watching. Bye bye.